All right. So these formulas are built to automatically handle your chain rule. So let's suppose that the u in here is just anything. Could be some really weird function, could be just a normal u, or could be x squared, could be whatever. When you do the derivative, right, you're going to plug the u in here or inside right here, and then do the derivative and plug that in over here. Derivative of u. So this formula takes care of everything. Okay, it just does it all at once. So now that we know the chain rule, we can just do it. So u prime is handling the chain rule, and we're doing this formula here. Okay. So if you do the derivative of the inverse sine or arc sine, it'll be this. So let's do the first example in the homework. And I'm choosing, again, so those of you who just got here, I'm starting with 3-7 today because it's simple and the other two sections are very difficult. So I'm going to save those for next week.
Okay.
All right, so find the derivative of f of x equal to arc sine. Let me switch over just a moment. Okay. So the derivative we said is equal to the little printout I sent you. The derivative of the inside, which is our u, over the square root of 1 minus that u, which is the argument of the arc sine or inverse sine. Okay, see what I'm talking about?
Yes.
So derivative of this is simply 1, right?
Right.
So that's pretty much it. We can FOIL this out, and that'll give us x squared minus 6x plus 9. Distribute your negative, add the 1, that'll be negative x squared plus 6x minus 9 plus 1 will be minus 8. Anyway, you see how we're just following the formula, right? Very straightforward. And any questions on what we just did?
No.
Okay, so you missed it one more time. Here's the formula page. No confusing. U is the argument, u prime is the derivative of the argument. Okay, let's do oops. All right, find the derivative of, just pick another one. It's number 3.
Actually, I have a question.
Mm-hmm.
So the question one, the x minus 3, why become, how does it become 1?
So the formula that we're using, the one I just posted, is the derivative of the argument. So what is the derivative of x minus 3?
That's the u.
Yeah, this is the u here.
Mm.
So derivative of this is 1.
Is it on the document you just provided?
Yes. So the document I just sent has the derivative of all the inverse functions, but for any argument of your inverse functions. So that one works better than some of the other ones in the book.
Oh, okay. Oh, is that this one?
Yeah, I put it in the chat box.
Thank you.
Yeah, no worries. So there's one for each one. So there's a sine. Let's do cosine, I guess. Okay, so the derivative of cosine is, so the 4 is going to come hang out. We know the whole thing will be negative 4. It's going to pull the 4 in front over here times the derivative of the argument over the square root of 1 minus the argument squared. So this becomes negative 4 times a half over 1 minus x squared over 4, which is negative 2 over 1. Yeah, I guess we could combine these, but we'll stop here. If there are any questions on how we use the formula?
No. Until you said this one's very easy.
Yeah, it's not too bad, right?
Right.
Just because it bothers me. This would be the same as 4 minus x squared over 4. Square root of 4, that'll come out as a square root. That 4 will come out as a half, right? So that's a fourth square root of 4 minus x squared. So that'll flip over and give us a negative 4 over. So this is the pretty version. Anyway. Let's do another one. Any questions on number 3?
No, just let me write down the last one. Just let me write down the last one real quick.
Uh-huh.
Okay, we can move on now.
All right, one moment. All right. So all your derivative rules are still in play. For example, number 4 requires a product rule. So in order to do the derivative, I got to do the derivative of the first function. So I'm basically doing the product rule times the second function plus the first function times the derivative of the second. So this would become 3e3x arc sine x plus e3x, and this is the formula again. So that'll be derivative of x over the square root 1 minus x squared. So we can factor the e3x and be done. So that'll give us 3 arc sine plus 1 over square root of 1 minus x squared. So I skipped a couple of steps, but you see that we're just doing the product rule, and then during the product we have to apply the inverse trig formula here. And any issues with this problem?
Is the exponent 3? Is that how you got the 3 in front of the e?
Yeah, there's a rule. Note. Oops, my pen's all weird. If your g is equal to e kx, then the derivative will be k e kx. So there's a 3 on it, just it'll be itself times the derivative of the top, basically. Yeah, I think that's actually better. Let me rewrite that different formula. Think of it as a chain rule instead. Times the derivative of kx. Yeah. So if it's a number, if it's x squared, or whatever, it doesn't matter. Find the derivative and multiply. You'll be good. Let's do one more. And I think that'll be it for the most part. I'll leave the rest to you. So h of x is equal to x squared arctan of 3x. So this time, I'm going to go ahead and write the chain steps we've been doing, just in case. The derivative of f will be 2x, derivative of arctan will be, on the formula page, I believe it's the derivative of the argument divided by 1 plus the argument squared. Okay. So let's just plug it all in. It'll be f prime g plus g prime f, which will be 2x times arctan 3x plus g prime, which is this garbage, times x squared. Yeah, this is pretty as gonna get, really. So 2x arctan 3x plus 3x squared over 1 plus 9x squared. And yeah, that's what they got on the homework. So they're accepted this way. Anyway, any questions on number 5?
Let me just write this down real quick because let's say +1 plus 9x squared.
Mm-hmm.
Okay. Here. And this is arctangent.
Mm-hmm. Yeah. I'm using the formula for arctan.
Okay, you can move on now. Okay.
Well, that's it for this section. I'm gonna leave the rest to you. Do y'all have any questions on the other homework or any concerns, any issues?
No.
Well, yeah, while y'all think about it, let me take roll.
I think we get all figured out.
Mhm. Where the hell is my? Okay. Is Romina here?
Yes, I'm here.
Cade Brown,
Here.
Megan Dean,
I'm here.
Alita Felton, no Alita, Dennis Garcia,
Here.
Sierra Jaramillo,
Here.
Nigel Macias,
Right here.
Macias, Delaney, Matthew Martinez, Sorab,
Here.
Brittany,
Here.
Gabriela Rodriguez,
Here.
Garrett,
Here.
and Haruka.
I'm here.
Okay. So you have any homework problems that you're struggling with or didn't understand, or y'all doing okay?
Yes.